The definition of rational expressions. In algebra, a rational expression is a fraction that contains polynomials in both its numerator and denominator. A rational expression is different from an algebraic fraction explained in tutorial 6.5 in the sense that the variables in algebraic fractions can also have negative or fractional exponents, indices, unlike in rational expressions, where the exponents of the variables are positive integers or zero, in the constant term. For example, we have the following shown on screen. Is an algebraic fraction, as it contains algebraic expressions in both its terms, but only the numerator contains a polynomial. The denominator of this fraction contains a variable in the power, -2, which disqualifies the entire expression from being a polynomial. Recall the term algebraic is used when there are variables represented through letters involved in an expression. On the other hand, we have the following shown on screen. Is a rational expression, as it consists of two polynomials that form the terms of a fraction. By definition, a rational expression is an expression of the form p x over q x, where p x and q x are both polynomials and q x not equal to 0. Obviously, an algebraic fraction can sometimes turn into a rational expression through a series of operations. For example, in the algebraic fraction considered, we can make the following transformations to turn it into a rational expression. We have the following shown on screen. The last form of the expression represents a rational expression, as it contains polynomial in both of its parts. In the transformations, we have used the property of fractions. We have the following shown on screen, which derives from the fact that division is a multiplication with the inverse. Obviously, not all algebraic fractions can become a rational expression, no matter how many transformations you make. For example, we have the following shown on screen. If we multiply up and down by square root of x to remove the only radical from the first term of the numerator, we obtain three other radicals in the expression. We have the following shown on screen. Therefore, this algebraic fraction cannot turn into a rational expression. Example. Write down the following algebraic fractions into rational expressions if possible. We have the following shown on screen. Solution. A. We have the following shown on screen. The transformations are valid only for square root of x not equal to 1, to avoid the denominator to be 0. This is a rational expression, as we can write it as the following shown on screen. B. We have the following shown on screen. It was impossible to avoid the radicals from the expression, so it is not a rational expression. That is all for lesson 11.4.2. To continue this tutorial, please watch 11.4.3. The disallowed values in rational expressions. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.